Hi everyone, I'm Nima, head of AI at Eigen. Joined with me is Dan and Ali from A16Z. Can you guys please give yourself an intro?
Hey everyone, it's great to be here. I'm Ali. I'm a general partner with the crypto team at Andreessen Horowitz. I've been at the firm for about 8 years. I actually have a bit of a background in AI and machine learning. I spent about 3 years at Google working on robotics and building a distributed system for fleets of robots. And then actually went to Stanford. That's where I got to know Dan, and that's also when I discovered crypto and blockchains, and have been following the space ever since. Excited to dive in and have a good conversation.
Yeah, hey everyone, I'm Dan Boneh. I'm a professor at Stanford. I work on computer security and cryptography. Been working in the blockchain space for a long time. Now we're getting also into the questions of security around machine learning. And yeah, looking forward to the conversation. And I should say I work with the A16Z research team closely. And yeah, looking forward to the conversation.
Awesome. Well, thanks for joining us. So given that we're going to talk about AI and crypto, and agents have been the talk of the town for the past 3 or 4 months, and then it kind of died down. Maybe we can zoom out a little bit in terms of why crypto and AI are interesting, both individually, but also the intersection of them, right? I think there's multiple facets of the intersection that are relatively fascinating, but unpacking that would be pretty good to get into. So maybe, Ali, what are some of the top things that you think are interesting from the maybe AI to crypto aspect, and then vice versa, AI to crypto to AI aspect?
Yeah, sounds good. Maybe I can give four different things that I think are interesting trends, and I'll just list them out quickly, and then we can dive into them later if we want. I think the first one is the the intersection of AI agents now being a thing, LLMs in particular, just AI agents and the kind of that centralized non-crypto world, with things like stable coins and blockchains that are now much more performant. And I think that the thinking here is that the dominant user base for the internet currently is humans, but that won't likely be the case for very long. And in the kind of the reasonably short term, AI agents will likely become the dominant user base for the internet. And one of the glaringly uh, missing features of the internet has been, since its inception, a mechanism for payments, a financial system for the internet, and that has basically been built around the internet in a way that has been fairly hacky, and in a way that is fairly manual and not really controlled by software. It's more controlled by human organizations, and kind of the actual process by which payments get made is uh, is fairly clunky. So crypto, I think, solves that issue, and I think will be the way by which AI agents can then participate in an actual economy that has an ability to make financial transactions. So that's the first one. The second one is the fact that AI will create like this overabundance of media that will be harder to know whether or not it's real. And so, for example, one of the important crypto projects in the space is WorldCoin, building out proof of humanity, which I think can help solve a lot of the issues with just not knowing whether you're interacting with a real human or not online, or not even not being able to know whether a piece of media that you're looking at is it corresponds to a real human or not. And there's like many other kind of second order effects of that whole kind of line of work within the crypto space. The third is decentralizing AI infrastructure. There are many projects that are building decentralized networks to help, for example, uh, build a network that provides compute for AI workloads that is not controlled by a single company, and instead is a network to which anyone can contribute and anyone can get compute from. And then the fourth one is what I like to call. I think Shriram actually likes to call. Shriram from Eigenlayer likes to call synthetic life, which is the ability to
Yeah.
use decentralized AI infrastructure to build agents that, in a sense, have a life of their own, and
Mhm.
again are not controlled by any one centralized company, and instead have their own kind of sort of, yeah, life of their own. And I think that there's many interesting applications or use cases for something like that. But I think things that we can get into, but I'll leave it at that for now. So those are kind of like the four big trends, newer trends that I think are pretty interesting at the intersection of these two worlds.
I have to say, I have to
Awesome.
add to the fourth one that actually blockchains is kind of an interesting way in which AI agents that kind of live on their own can generate their own income. So you can imagine an AI agent that makes interesting tweets, and as a result, fans basically send in money, and then it can use, and of course they do that. They need a form of digital money, so blockchain makes sense for that, and then the agent can use that to improve itself and get better over time. So there's kind of going to be an interesting interaction with agents that actually can generate their own income. Maybe I can build on what Ali was saying and give a few more
Absolutely.
examples. So to me, I have to say one of the exciting interactions between blockchains and AI is the fact that there are technologies that are developed in one space that are applicable in the other space. And maybe I'll give like one example that I really love, and that's this question of verifiable AI. Yeah, how do you verify that when a model runs remotely, these models typically run in the cloud somewhere, how do you verify that the results that you get back were actually generated correctly relative to the correct model? And that's an area actually where technology that was developed for blockchains because of blockchains actually can help with AI, which is, I think, really, really interesting. And of course, the technology I'm referring to is what are called proof systems. Yeah, but they're also known as SNARKs. Zero knowledge proofs maybe is a very common name for these things. So this is technology that was developed to scale the blockchain. But now that the technology, and it's been, by the way, under development for for over a decade, practical development to make it commercially viable. And now that that the blockchains make this real, all of a sudden there's like a whole bunch of applications outside of blockchains that can benefit from this, including AI. And so, just one quick example: if suppose you want to outsource, you want to interact with a model that runs remotely. Well, maybe that you want to make sure that the model is actually running correctly. Yeah, so that the results you're getting from the model are actually consistent with the model that you expect to be interacting with. So one way to do that is another technology that's useful for blockchains, which is using trusted execution environments. So you can run the model inside of a trusted execution environment, and the hardware tries to guarantee that the model runs correctly. And actually, this is a big deal. Your listeners probably know NVIDIA now released a trusted execution environment inside of their GPUs, inside of the H100 and H200. Those are going to get a lot more usage in the near term. So we'll be seeing sort of secure, the model is running inside of a secure enclave, and the enclave attesting that the model outputs the results correctly. But the question is then, is there a way to do this without relying on hardware assumptions? Yeah, so we don't want to rely on the fact that the hardware has not been compromised. And that's actually a really interesting applications of these zero knowledge proofs. They allow you to prove that things ran correctly, and it's quite easy to verify that they actually ran correctly. And so the way you would do that is you would issue, so the person who's actually running the model for you would commit to the model weights. So the commitment becomes public. The commitments are very short themselves. And then every time you issue a query, they will respond to you with a proof that actually the inference was done correctly with respect to the committed model. So now you can quite easily verify that the response that came back really did come from the committed model. And you can do that actually fairly decent speeds these days for not for outrageous models, but for moderate sized models, it's you can do this in decent speeds. Maybe I'll just quote some numbers. I think your listeners probably want to know how close this is to practice. So there's actually a very recent result. This is using the expander prover. There are many provers that are used for proving inference. A very well-known one is called Ezekiel, EZKL. That's a library that will generate proofs for many types of models. I'll mention results from Expander. Expander is they published these numbers very recently. So they say that basically for image classification, so models that are say 15 million parameters, so not super big. 15 million is not too big. On a single-threaded laptop. Single-threaded, yeah, you can generate one proof per image in about 2 seconds. Yeah, so and then by the way, proof generation parallelizes quite well. So of course you can throw GPUs at it, you can throw multi-core machines at it, and it scales quite nicely. So that's for image classification. If you want, of course, everybody these days is interested in LLMs. Yeah, no, everybody just wants to talk about LLMs and what they can be used for. So with LLMs, things are not as good. So just don't get excited before you hear the numbers. So just to tell you how well they perform, so if you look at a model that has 8 billion parameters, it's not too large a model, but not small either. So there, again, on a single threaded laptop, they can generate one proof per token, well, in about 150 seconds today. Yeah, but these numbers keep improving, and again, with GPUs, you can make them better. So today, I wouldn't say that for LLMs, 2 minutes per token is probably a little bit too much to wait. But these numbers are getting better, and as I said, we can always throw more hardware at it. So to me, the exciting thing again is if we zoom out, is that this technology has been developed for blockchains, and now all of a sudden it can be used for verifiability of inference.
Yeah. Okay. There's so much to unpack across all the things that Ali and you just mentioned. So going back to maybe the very first thing, Ali, was this trust problem that you mentioned. There's this interesting framing of AI currently has this trust problem. We don't exactly know how it works or like who owns it and how the model weights get updated and so on and so forth. And then we realize that crypto also has this apps problem, right? So far that we're trying to figure out what the exact value proposition to the users are, right? And we've made significant progress, and we're starting to see early signs of that. But that's been sort of the perception, right? But now, with the recent AI capabilities, like these LLMs and generative capabilities, we realize that these two are a fairly good match made in heaven, right? Because the crypto aspects of blockchain tech, ZK and so forth, can solve some of the AI issues, and vice versa as well. Like AI lends its capabilities to making crypto more viable for mainstream adoption. And one thing that I think is interesting to dive into is this aspect of the autonomous life, right? If agents can live on their own on the substrate that is essentially unstoppable compute, right? Because that's what Ethereum, Bitcoin, etc. are. If agents can do that and learn and become better, there's this essay that one of the godfathers of reinforcement learning just released called The Era of Experience, right? Where the data that we use to give reward signals to these agents and how they can learn is sort of becoming a bottleneck at this point. And maybe the more generalizable way of approaching how these agents can learn more broadly is just literally through experience, right? And going through the edge cases of what that experience actually means is probably the direction that seems very promising. And doing that again in an unstoppable way of getting your own currency, compute is their currency, right, of agents. So if you can sort of persuade and solicit funds to be added so you can buy more of your compute and learn and so on and so forth, I think that's a very interesting design space that we're going to tap into fairly soon. And this may be something that overlaps with some of the stuff that you worked on the fleet, right? Maybe, or some of the robotic stuff that you did. So how does that overlap with what we may see come to fruition pretty soon?
Yeah, what I like about the synthetic life idea is that it's probably like the culmination of all of these other trends coming together in allowing for something that's far far more futuristic to really become possible. I would think of it as much more far out because we do have to build out all of the decentralized AI infrastructure on top of which these agents would run. We probably have to build the capabilities around the financial system so that these agents can then participate in a real economy and be able to earn an income and be able to sustain themselves independently, be actually sovereign and not beholden to any one individual or any one centralized company. But I think actually one of the most interesting questions is why, like maybe as context for your listeners, like why is it that this is a cool idea, even though it does
Yeah.
sound like it's a fairly science fiction idea? Why would you want an AI agent to have a life of its own and to operate without interference from anyone, even the people who built it, or the people who wrote the code for it, or the people who control the physical machines that run it. And the answer to that is that, uh, as an example, you could imagine in like a fairly reasonable sort of near future, you could imagine that children have a kind of mentor that is an AI that lives life alongside them and understands their needs, understands the way that they prefer to learn, uh, is able to mentor children in essentially learning and growing up and kind of becoming capable in the world. And you would think that having that agent be controlled by a single kind of centralized company wouldn't be ideal, because that
Mhm.
company could at any time decide to, for example, change its pricing, or could decide to shut it down, or decide to change its functionality, maybe because of political reasons. All of a sudden, the kinds of things that it can talk to you about change and are no longer as kind of open as maybe they used to be, or as you would want them to be. And then also there's the data component. You'd want to own all of the data and kind of really have control and ownership over this agent, if it is really going to be your mentor throughout life. And so the only way that you could do that is if it is based on decentralized infrastructure. And that
Mhm.
to me is maybe like a good example of a use case for this kind of crazy science fiction idea. Um, and it maybe motivates why it's something that we might want to build. And there may be many other examples where either individuals or companies may want to directly own their
Yep.
agents without necessarily themselves running like all of the infrastructure and having to run,
Yep.
for example, servers in their closet, uh, or even servers in the cloud, to actually have that kind of relationship with their agent. You may want it to be something that just actually runs in decentralized infrastructure that you then have access to. So
Yep.
anyway,
Yeah, I mean, the other field that comes to mind when you mention that is like, the medical field, right? When you have discoveries or practical applications of this kind of stuff, then who actually controls that, and how does that end up being applied in the industry, right? Because it can help millions of people potentially, right? But who ends up controlling that and how they benefit from it becomes pretty questionable. So maybe like on this topic of like who controls it, and maybe how you can verify ownership, how you can verify inference, where these things run. Dan, I know you mentioned that, but maybe we can dive into algorithmic fairness and things of that nature that you think can cover even more of the whys of why we want these things to be, decentralized. Because I previously might have mentioned that in the financial case, but yeah, here too. Love to hear some of your thoughts.
all right, thoughts about what about algorithmic fairness?
Right, and more generally, verifiable inference, how we might want to have transparency and visibility into the commitments that get made around how these models are produced and used.
Yeah, well, this is where a lot of the ideas that Dan was just talking about come into play. You would want the ability to know that the model that was run, if it was run by a
Mm.
centralized company, you'd want to know that it was run in a way that's as uniform across all users, for example. Like maybe you have some sense of which model was run and what its parameters are, what its properties are. And the only way to do that is to have some kind of verification system, whether it be based
Mm.
on a untrusted hardware, as Dan mentioned, where you would have remote attestation. The hardware would attest to the actual
Right.
code that was executed within the enclave, and you would get that as a sort of proof that the right code was executed. Or it could be more cryptography based on zero knowledge proofs,
Yep.
which similarly would give you that same kind of confidence. Um, and I think that the use cases for this, like one example for where this may be important, is if an agent or machine learning model is being used for determining uh, your kind of insurance premium or something like
Hmm.
that, and you want to know that the model is a kind of a standard open source model that doesn't discriminate across like various different dimensions. Having the confidence that the model that is open source that everyone can see is actually the model that's making the decision as to whether or not you get insurance or what your premium is, is something that may be useful to offer. And this is basically just pure cryptography. I don't think that there's a blockchain involved in doing that.
Well, but it's made possible because of the developments that happened in blockchains. The fact that we can do provable inference now, that was not possible a few years ago, and now it is possible thanks to the blockchain. Maybe one example I'll mention that you can prove is these days, like for example, like Ali was saying, you could imagine a model that decides whether your mortgage application is approved or not. Yeah, in fact, some banks are starting to train models to make those decisions. For immediate loans, some models are being used to decide that. There's some regulatory requirements to provide an explanation if the application is rejected or accepted. The company is supposed to provide an explanation to why did the model accept or reject your application. And it's interesting. There's a standard industry algorithm. It's called LIME, LIME, that's used for generating explanations. Maybe I don't need to go into the details of how LIME works. But I'll just say in one sentence, it kind of approximates the model as a linear model around your particular input, and then that linear model is the explanation. And one thing that's quite interesting is, again, because these proof techniques have become so applied, so practical, that we can actually generate verifiable explanations now. So you are sort of, as a customer, you are getting a result saying your application was accepted or rejected, but in addition, the result comes with an explanation and a proof that says this explanation really did come from the correct execution of this LIME algorithm on the model that was just run on your data. So it's really quite remarkable that we've because this technology was developed by blockchains for blockchains, this is now something that can be used to verify things like explanations. So.
Right. Yeah, I've been thinking about that in terms of enforcing the correct incentive alignment, right? And how do you actually have visibility into that? If a bank says that they'll do something, right, and has certain policies in place, did the product that they give to the users reflect those policies, and how can the users essentially prove that? But
yeah, and exactly.
And extrapolate this to other sensitive
and
use
now you
cases.
don't have to trust the bank to say, "Oh, trust us, we implemented these policies." Now the bank can actually provide a proof that they actually did that correctly. And I have to say this question that you brought up and that Ali was building on too is this question of we're going to be interacting with these agents now on a fairly regular basis. You can imagine giving them fairly personal data, whether it's commercial IP or even just your own personal data. Your movie likes, your personal preferences. It's quite important that this data that normally you would keep this data to yourself, but now you're normally interacting with these agents, and you provide them with this data. It's kind of important that this data be kept private to you. Yeah, and again, this is kind of where trusted execution environments come in. So there's actually quite a lot of work in running agents inside of trusted execution environments. So even the operator of the model cannot see the data that the model is operating on. Yeah, and so we're going to see a lot more of that. And that's all connected to, as you said, when you run these agents distributively, you could visualize a blockchain that where the nodes in the blockchain themselves are running hardware enclaves. Yeah, and so that even though the model is distributed, people tend to equate the model running in a decentralized network as if everything about the model is public, like the model weights, the model data, and so on. That doesn't have to be. Because of these trusted execution environments, you could actually have a decentralized agent that still keeps your data private from the operators of the network.
Right. Yep. Maybe we can also shift gears a little bit in towards how these models that these agents rely on get produced, right? Right now, we may be tapping into some of the closed source providers for these functionalities, but then we also have some open weight models, right? Given that there is this perception that crypto introduces scarcity and hardness, as the commitments, with the properties of Bitcoin and cryptography and so on, versus the abundance mindset that AI creates. Maybe we can talk about how some of the crypto primitives actually do allow tapping into a larger compute substrate and enabling maybe decentralized training runs that do give way to even a more open model of creating these models so that agents can, have an even more level playing field, and in terms of how they maybe accelerate in capabilities. In terms of how the massive supply of compute right now, right, that exists, how that's being tapped into maybe for decentralized training runs to give way to open weight models, even more so than we have right now. We have a few right now, open weight models, but you probably also want to, from even more upstream, have a better handle over how these models are created, so you can incentivize that model creation to be better and better and better.
There's a couple of ways to unpack what you just said. Maybe one thing to talk about is the fact that what is the economic incentive for open weight models, right? When somebody publishes an open weight model, in some sense, they spent a lot of effort in training it, but now anybody can use it, anybody can train on it, and so on. So it's interesting that, we keep coming back to this. I didn't mean for this session to be on that, but we keep coming back to these trusted execution environments. But it's quite interesting that even though you have an open weight model, it doesn't mean that when you run the model on your machines, you need to be able to look at the weights in the clear. You could imagine somebody training a model, but when it runs on your machine, it actually runs inside of a trusted execution environment. And so, okay, maybe this is a longer conversation, but there is a model in which you could train a model even maybe on public data and try to make the weights available and still try to make a profit from the fact that you trained that model. So that's maybe one direction to take what you're saying. Another direction maybe is this question of when you outsource training. So suppose most companies can't train models themselves. They have to outsource it to third-party providers. Maybe this is the abundance you're referring to, that maybe these third-party providers will use any access capacity on GPUs to do the training. So now all of a sudden, these third-party providers are outsourcing the training job to yet other parties outside that have access GPU capacity. Well, now how do you know? All of a sudden, you have these people who you don't trust who are training models for you. How do you know that they trained the model correctly? Yeah, so how do you know that they used the training model the training data correctly? How do you know that they ran the model, they ran the training algorithm for enough iterations? How do you know they didn't put a backdoor in your model, right? So there's all these verifiability. This is called verifiable training. How do you verify that the training was done correctly? And it's interesting that that's actually another area where AI can benefit from technology that was developed from blockchains. Yeah, and what I'm referring to is these optimistic methods that were developed in the blockchain space, right? So in the blockchain space, one way we can verify something is we can have one person do the computation, and then other people verify that the computation was done correctly. And if they get a different result, they can complain, and that causes an undoing of the incorrect computation. Yeah, so we call these optimistic approaches for computation. This is very common in the blockchain space, and lo and behold, optimistic methods can also apply to AI training, right? So you can have someone work hard to train a model, and now you can have other people go and verify that this training was done correctly by redoing maybe the whole training or maybe parts of the training, and see that they actually got the same results. So that's applying optimistic methods to machine learning training. And to me, what's fascinating is that doesn't actually work. Like if you try to do it off the bat, you run into these really interesting questions of what's called non-determinism. Yeah, if I train a model on one GPU and you run the exact same algorithm to train exactly the same model on the same data on a different GPU, you'll get a different model. It's really quite remarkable that these GPUs introduce non-determinism. And the non-determinism comes from floating point errors. Yeah, on GPUs, if you compute, A plus B plus C or A plus B plus C, yeah, you're supposed to get the same answer. But because of floating point precision, all of a sudden you get answers that are close to one another, but not exactly the same answer. And it turns out training is such a compute intensive operation that even tiny errors during training will cause the models to completely diverge, and you'll end up with completely different models. Yeah, so optimistic methods don't directly apply in the context of verifiable training, but it turns out you can make them apply. And there have been a couple of papers, including some of our own work, on how to remove non-determinism from training so that you can actually use optimistic methods to verify the training was done correctly. Yeah, and so even though naively it doesn't work, we actually know how to make it work. And that's kind of a pretty interesting direction of research. And now there's a couple of papers on this. So yes, and there's even companies that are now deploying these optimistic methods for verifiable training. Yeah, so I hope that kind of addresses the abundance questions you brought up.
Yeah, for sure. I mean, Ali, I don't know if you want to say anything about that or if you think Dan covered it pretty well.
Well, I mean, it's a related problem that emerges because of this latest wave of AI, which is that the entire business model of the internet ends up breaking, because whereas previously you would actually have to go, like for example, you would go to Google and you would make a search and you'd receive certain ads, and then there would be websites that you then go visit, and everyone involved in that whole process has an incentive to get your attention, and all of that breaks down when now instead of going to Google, you just interact with an LLM, and you don't necessarily get directly exposed to ads, and you also don't necessarily go visit individual websites, and instead you just interact with the LLM directly. In that world, a lot of the way that the internet is built ends up breaking down, and the kind of the business models that make the internet work today no longer work. So there's a big question of where we end up. What is the new equilibrium now that LLMs might actually become like the dominant way by which people interact with the internet. And one open problem that I think could be, if we had an answer for, could be the solution, is figuring out attribution in the training of an LLM to understand how much each piece of data that went into the training actually contributed to any one particular output from the LLM. So we could know that like some article from a particular media outlet was a big contributor to a response that an LLM gave, then you could then build new business models that somehow allow for some of the money to flow back to that specific media outlet. And all of that, by the way, could be powered by crypto. You can imagine building a crypto system that helps both track attribution of who contributed to an LLM's training, and then also compensates those people, the people who contributed, whenever the LLM makes responses that leverage those inputs. So it'd be interesting to see. Like, I think it is a very difficult problem to solve, but I think I'm kind of an open question. I don't know, Dan, if you've seen anything along those lines people are working towards.
Yeah. Oh, this is a pretty hot area. How do you evaluate the quality of data that was provided for training? And then potentially compensate for it. It's a very,
And
very
it's quality and relevance. Quality and like how relevant it is to any one particular query would be kind of the gold, kind of the holy grail.
Yeah, it's a very difficult problem. I'll tell you the first thing that comes to mind, or kind of solutions that quickly come to mind, actually don't tend to work well. Like maybe just to give one example, like you could imagine training. Suppose you want to evaluate the value of a particular article that I provided to train a model. You could try, at least as a thought experiment, you could say, well, let's train the model with my article and let's train a model without my article. And then let's test the two models and see the difference in quality. And the difference in quality would be the amount of compensation I get from my article. Turns out that doesn't work. Yeah, it turns out there's lots of ways to game that kind of naive algorithm that I can contribute. Like I can get together with a bunch of people so that individually it looks like we all made enormous contributions, even though overall we didn't make that much of a contribution. So this question of evaluating data, how do you also, this brings us immediately also to the question of provenance. Like if I supply an article to train a model, how do you know that I'm really the creator of that article? Maybe I just ripped somebody else off and use their article as the result, and then who should get the compensation? So all of a sudden, it immediately brings up questions of provenance. and so on. So yes, it's a fascinating area. There's lots of work on this topic, and it turns out to be actually obviously quite difficult. Everybody is now very hungry for training data, and compensating people or compensating organizations or people for their training data is a very interesting question.
Maybe something that we can unpack briefly is this concept of watermarking, right? That might potentially be relevant in this case. So, can you comment on why or why not it might be relevant for retaining sort of this provenance that you talked about?
So watermarking is kind of a way to try to embed provenance information in the content itself. Usually,
Mm.
watermarks are not that robust in that the content can be modified, so the watermark is much harder to detect or recover. I'm much more in favor of using obviously cryptographic techniques for ensuring provenance. So the content would be signed, and content that isn't signed would actually be ignored. Yeah, so the content would be signed by its creator, and that would give and potentially that signature, the creation process would be recorded on something like a blockchain, so that you actually have a timestamp for when you created the content. Um, What's interesting is there's actually a standard that's forming that I think it's important for people to know. There's a standard called C2PA. It stands for Content, Provenance, and Authenticity. It's a consortium of companies. The idea is that basically every piece of content that's generated, let's say cameras capture video or images, a Gen AI model generates some content. Every piece of content will actually be signed or it will contain what's called the C2PA attestation as to who created that content. Yeah, and now if you try to upload something to TikTok or so, if it doesn't have a C2P attestation, they can't verify provenance, and the result they'll just ignore it. Yeah, so it's so kind of the world we're moving towards, exactly because of Gen AI, because we're going to be interacting with a lot of content, and we can't tell if it's real or if it's generated. That things that don't have C2P attestations to them could very likely be ignored, and so that everything would have to have a C2P attestation. And in fact, there are already cameras on the market. Yeah, that when you take a picture, they will attach a C2P attestation to the picture. So Sony, Leica, all those Panasonic, all these companies have cameras that actually produce these C2P attestations. And even Gen AI models, like some like DALI, for example, when you ask it to generate an image, it will attach a C2P attestation to that, saying that they generated the image. So it's kind of an interesting world that we might be moving into. This is probably a little further down the road, maybe 5, 10 years away, that everything will have sort of provenance information attached to it, and something that doesn't, simply people won't interact with it. Yeah, and that actually, I have to say, raises lots and lots and lots of really really interesting questions. Um, Maybe just to give one example, yeah, of a C2PA
Yeah.
question, which is to say that let's say you want to do minor edits to the image. Let's say you want to resize it or you want to crop it. All of a sudden, you lose the C2PA attestation because you can't verify the signature once you start making modifications. And so the question is how to deal with it. And again, there's all sorts of really interesting cryptographic techniques that let you allow you to make changes and still retain the C2PA attestations. Yeah, so I guess I just wanted the listeners to know
Yep.
that there are technologies that are being created for provenance purposes.
Yeah, absolutely. The reason I think it's interesting to dive into some of the specifics here is because a lot of the work that is going into the intersection of how cryptography can be applied to just frontier AI systems is rooted in a lot of practical use cases, right? Whether it's who ends up getting compensated, who has ownership over what, how their behaviors get modified as a result of using these products, how these systems get built, right? I think going back to whether it's like the financial use case or the photography use case that you just mentioned or what have you, how this next wave of next generation of products is getting built. I think asking these questions is pretty critical, given we've witnessed what happened over the past, let's say, like 10, 15, 20 years of consumer internet having evolved the way it did and seeing the repercussions of it, right? Is there anything specific on that note, Ali, or that Dan, you want to mention about that you think is particularly interesting for what we might see in the next wave of applications or services? Maybe one thing I can kick that off with is We talked about how for training that gives you a different sort of economic model for why participation might be interesting. But more broadly speaking, what business models can become viable with adding crypto to AI or AI to crypto that you think is interesting?
Well, so I think maybe in the category of decentralizing AI infrastructure, the interesting thing there is that it may be possible to tap into a large amount of compute that's latent and idle that currently isn't really being used. That either exists in data centers where utilization is not close to 100%, or even in
Mhm.
consumer like laptops that have a like I say like something like an Apple M chip, uh,
Yep.
or a GPU if people have like gaming computers or things like that. Um,
Hmm.
all of that right now isn't really utilized at all. And there's one particular narrative of building a network that is able to tap into all of that by allowing people who have that compute to contribute it to a network and to then
Hmm.
allow other people on the demand side who want to say train an AI model or want to do inference on an AI
Hmm.
model to be able to tap into all of that compute. And the business model, the natural business model would be to for this network to essentially be a kind of marketplace that
Hmm.
takes some cut of all of the transactions that happen that the network enables. Um, and it would be a business model both for the people who have this hardware who otherwise would not be able to monetize it, and also for the people who built the network. And it would be a way of providing a service to people on the demand side that potentially could be cheaper than going to a centralized alternative. Though that is an open question because it will depend strongly on all of the questions around how do you make this verifiable. And if the
Hmm.
verifiability of the network is expensive, then the economic argument may not work, but there may be other reasons that you may still want to go with decentralized infrastructure, kind of like the synthetic life use cases or other use cases that
Yep.
really benefit from the underlying infrastructure being decentralized, which are all
Hmm.
use cases that would like to protect themselves from any form of platform risk, where the underlying provider could rug you if it's centralized. Um, so that's one example of a kind of a new business model that may emerge thanks to some of these new primitives.
Yeah, this is something that we're seeing a lot at Eigenlayer actually, because this framework of ABSs, right? This four-sided server marketplace where people can supply stake, and then operators can use that stake to run some service verifiably, and then consumers can obviously use that service, given that there's economic stake in hand. People have been getting very creative about looking into decentralized training runs, verifiable inference, even running agents themselves in the context of an ABS, because precisely the compute providers can come from anywhere in the world, and the stake can come from anywhere in the world to assure that whatever operations the operator is running is made verifiable. Otherwise, it gets slashed, right? I think over the past half a year, a lot of the folks who have been thinking in the right pockets of AI and crypto have been reaching out to us for how Eigenlayer can uniquely sort of give them a substrate for what they're trying to do across the AI stack to make AI end-to-end
And
verifiable.
maybe it is good to just reiterate that there's kind of three general categories for verifiability. Yeah, I think we talked about
Hmm.
trusted execution environments for verifiability. So you can let somebody run
Hmm.
and do the training or inference for you. As long as they're running inside of a trusted execution environment, you can verify the results. So that's one. The second one is the zero knowledge techniques, where you can prove that you ran the algorithm correctly. For training, this seems to be a little too hard right now. Training is too computation heavy to use proof techniques. And the third one is optimistic methods, where one person does the computation and other people check the computation. So those are the kind of generally the three buckets, the three techniques we have for verifiability. Um, and they're like companies that are deploying kind of all three in the context of machine learning. When as Ali was saying, you're using access GPU capacity to do training and inference.
Yeah, I also think if we zoom out a little bit for when this infrastructure has matured a little bit more, right, and we have more performant blockchain just systems, as LLMs also get more capable, how do you think robotics will evolve, right? Because they're essentially just physical embodiments of LLMs or agents, right? So how do you see that sort of unfolding?
Seems to be almost entirely separate from crypto, but I think that robotics
Right.
is much more likely to happen in the shorter term now that I think AI is ramping up the way that it is. Like one of the hardest problems in robotics has always been reasoning about an unstructured environment and being able to manipulate objects in an unstructured environment. And I think some of the new techniques that have emerged in the last couple of years, LLMs included, but not just LLMs, have allowed for the space to move forward dramatically. I think also the world of robotics has this issue where there's two very difficult problems. One of them is the problem of intelligence. How do you reason about unstructured environments? How do you operate in them? How do you do something useful in a way that's autonomous? And then the other problem is the problem of cost, just manufacturing a robot that has precise enough actuators that's able to do something meaningful in the world. And these two problems are in tension with one another in that if you want to have a robot that's cheap and is not extremely precise, then you need far greater intelligence to be able to compensate for the imprecision in software. And conversely, if you want a robot that does not have strong AI, that maybe has preliminary or rudimentary intelligence, then you need far greater precision in order to be able to kind of operate in the world with better confidence. But now that the intelligence side is improving dramatically with all of these recent developments, it's possible to bring the cost down of actually producing a robot, because now you can compensate for a lot of the imprecision of cheaper hardware using intelligence and using software, which is very exciting because it means that it may be possible to build robots that do not cost $250,000, and you could actually maybe buy, like it's conceivable you could build a robot that could actually be a consumer product that people could have in the home eventually, and it would do useful things like empty the dishwasher and do your laundry and make your bed and whatnot. In part because the intelligence problem makes it so much easier to make the hardware manufacturing cheaper and more accessible.
It's gonna get pretty wild, I feel like. But
Yeah.
maybe a tangent to this is the legal infrastructure, that we're gonna need to be able to assess how these systems get deployed, right? Yeah, I feel like for how capable these LLMs can become, and just other mechanics of just robotics in general as well. Is there anything that you've been thinking about from the legal infrastructure and how we might be ready or not ready in how these systems get deployed?
Maybe I'll say here just a few words about like the fact that LLMs are in some sense a dual use technology. Yeah, let me explain what I mean by this. So we've been doing some work, and others have been doing some work on this question of whether LLMs can find exploits in software. Yeah, can they find vulnerabilities and can they build exploits automatically? Yeah, and it turns out they can. Not too surprising. And in fact, we just recently built this benchmark. It's called SciBench, that has a bunch of very difficult capture the flag competitions, where capture the flag CTFs are competitions where human teams compete in solving these CTFs, and it turns out that these models are not quite as good as humans. They can solve about 10% of the difficult CTF, the hardest CTFs that humans can solve, but that's already quite impressive. They already are able to find vulnerabilities and build exploits against bugs and software. So I want to stress, though, that this is like really dual use technology. Obviously, people immediately start to think about the negative applications where an attacker would use an LLM to build exploits. But there are lots of positive applications where now, before I ship my code, I can run an LLM on my code and do testing for security testing on what I'm about to ship, and then fix all the problems before the code actually ships. Yeah, so it's a way for people to kind of strengthen and find bugs in their own code by applying a security LLM to their code. So you brought up the legal questions, and I just want to stress that in in any of these, many of these applications are what we call dual use. They can be used for offense, but more importantly, they can be used for defense, and that actually is going to dramatically increase the quality of the code out there in the wild, because everybody's going to run these tests before they ship code, and they just quickly find bugs, and you can fix all of them before you ship.
Right.
Yeah, so it's quite, yeah.
Well, I mean, so you said there's offense and then there's defense, right? So is there anything on the offense you want to talk about?
No, I would rather focus on the defense, because I think that's kind of the interesting application, right? So the fact that LLMs can
Right.
be used to strengthen our code bases, to me, is fascinating. I mean, maybe this is how we avoid many of the security problems that have been plaguing our running code. I'll tell you even more. I mean, there's a lot of work. For example, you know that many of the security problems in the real world come from the fact that we're using languages like C and C++. It's very difficult to write secure code in C and C++. There's this general move towards more secure languages like Rust and others. And it's really quite interesting whether LLMs can actually help us, maybe even automatically translate legacy C++ code into Rust code. So presumably, keeping the same functionality minus the security bugs. Yes, and so that all of a sudden the existing infrastructure that we have, like even the software that we're using to record the session, that's all C++ code. Maybe using LLMs, that could all be made into Rust code and avoid many of the security vulnerabilities that exist in these systems. So I'm very excited about the positive applications. It's a little bit of a risk that it's unfortunate we immediately run to the offensive applications. There's a little
Hmm.
bit of a risk that because of the offensive threats, we might not be able to reap all the benefits of all the defensive applications of these technologies. And so I hope that people do focus on the fact that these are really important defensive tools for strengthening software.
Dan, have you seen people? I'm sure you've seen people use LLMs and formal verification
Oh yeah,
in
yeah,
order
for
to
sure, for sure.
generate
This is a
code
growing
for
area
you.
too. Yeah, whether we can generate form. Lean is like a very popular language for Lean and Coq are popular languages for doing formal verifications of software. And yeah, you can totally try to use an LLM to generate these Lean proofs. Um, I think that doing Lean proofs for large software is hard for humans, and it's also hard for LLMs. But
Yeah.
obviously for little functions, little subroutines, now maybe we can automate proof generation, and again, that's going to be a tremendous improvement in software quality. Yeah, it's a great point.
Yeah. Slight reframing on defensive and offensive technology. I feel like the way that these LLMs have an impact on people's psyche has also been starting to kind of, be showcased more recently, right? For how these models are fine-tuned or how they're trained or, etc. And how much of an emotional kind of reliance we end up having on these as products, right? And what that essentially could do. So maybe touching on that a little bit, how do you see the relationship that we have with these LLMs evolve as they get more capable? And because some people have been using them as as tool calling gets better, some people have been using them as very reliable products to become a lot more efficient, right? This term of like agency has been talked about, so people can do more. But at the same time, others have kind of questioned whether sort of delegating your thinking, right, to smarter reasoning capabilities could actually lower your cognitive baseline. So you could think about it in like either direction. I obviously I'm a bit more optimistic that you can do a lot more now and have access to like a lot more knowledge and reasoning capabilities. But yeah, curious to get your takes on either of those directions.
I think it just increases the variance of the distribution, and to some extent actually makes it even bimodal, where you can use LLMs for either making your work much easier and then removing any kind of cognitive load that you would otherwise have to engage with, in which case maybe you do lose some of the skill that you otherwise you'd be forced to develop. And who knows whether that's even a problem, because it may be fine to
Hmm.
in the same way that we leverage computers, right? We leverage all sorts of tools to make
Yep.
our lives easier. That it may be fine for people to leverage LLMs for some of the kind of work that they would have had to do themselves before.
Mhm.
But that's maybe one side. On the other side, you can use LLMs to supercharge your learning. And actually, a friend of mine has a niece and a nephew, and he gave me this. He told me this story about how they had a very different approach to using LLMs. Both of them had some kind of math problem set or math homework that they were doing. They're both like maybe 12 years old or something like that. And his nephew used an LLM to basically get all of the answers to the problem set, whereas his niece used an LLM to generate additional problems that were kind of extra beyond the problem set to kind of supercharge her learning. And so that's like a
Wow.
kind of a good example for how you can use this technology in whichever way you want, and the people who decide to use it for learning and for enhancing themselves and growing more will
Right.
likely be farther out on the distribution than anyone currently is. And then the people who decide to use it in the opposite way will probably end up further left on the distribution than anyone currently is, or most people currently are, which leads to this kind of bimodal type of distribution of outcomes. The technology is just a tool. You can just decide how to use
Right.
it, how to leverage it.
Actually, I have
That's
to add to
cool.
this. It's a really interesting story. I think that also the dual use nature of LLMs for education. So obviously, like Ali was saying, people we're very worried that we put out a homework assignment or a final exam, and people just use LLMs to solve our homeworks and our final exams, and it works. It's really freaky. I mean, they you can really take a like literally you take a picture of the homework assignment and it just spits out all the answers. It's wild. But
Yeah.
so I mean, immediately people go to the negative applications, but there's amazing positive applications for education, and I want to give you just one example. So one of our professors who teaches the algorithms class, what he assigns as a homework assignment now in the algorithms class is he teaches, for example, a sorting algorithm like quicksort, and the students' homework assignment is go talk to ChatGPT and convince ChatGPT that you understand how quicksort works. Yeah. So the prompt to ChatGPT is interact with the students, make sure the student understands how Quicksort works, and when you're convinced, let me know so that the student gets a check mark that they convinced the model. And now the student basically they learn how Quicksort works, and now they have to convince ChatGPT that they understand how it works. And it's wild to see this in action. It's like you the student, can kind of write a description of Quicksort in your own words, and then the model starts asking you, well, how do you do this step, and how do you do that step, and you have to explain more and more detail. And then the model is not convinced, so the model says, oh, let's run through an example and show me how it actually works on this particular example. And it takes a while actually to convince it that you understand how quicksort works, and then once it's convinced, it finally gives you the check mark, says yes, I'm convinced. And the amazing thing is that this was also used in ETH in Zurich. They did an A/B test on students who used the model and did the homework assignment versus students who didn't do the homework assignment and convinced the model. And it turns out the students who used the model to convince the model that they understand how the algorithm works, they did much better on the final exam in the course than students who didn't. Yeah. So this is like an amazing education tool. There's just no way to do this without a model, right? You would have to hire, an army of TAs in order to talk to each and every student and have them make sure that each and every one of them understands how Quicksort works. That's an amazing
That's
application.
pretty incredible.
Yeah,
Incredible.
yeah, yeah.
Of course, if a student really wants to, they could just use an LLM to use.
They can point one LLM at another. Yes, for sure. There's always a way to cheat.
Let's not go there
Yeah,
yet.
but I also on that line I also want to maybe mention a cautionary tale, because you asked a very good question, which is if we start to rely on LLMs, does that mean that we lose some cognitive abilities ourselves? I think the classic example is, since GPS came around, I still don't know the geography of the city that I live in because I just rely on GPS for everything. So we kind of lose a little bit of cognitive ability. And I just want to give one cautionary example there, which is code generators. Yeah, so developers, it's incredible how effective code generators are. You can, as a developer, you can make like a change to an API to a function, and then you just tell an LLM like Claude or so, go fix all the calls to my function to use the new API, and it just does it in 1 minute. Something that would take you hours of work normally. Yeah, so it's an amazing accelerant. But the cautionary tale is people we've seen examples where people asked the code generator to generate, they write some metacode, pseudocode, and they ask the code generator to generate real code from their pseudocode. The code generator will do it. Will generate code that works. The problem is the code will also have security vulnerability in it. Yeah. And so you can't trust code that comes out of these code generators. You have to look at the code and verify that, well, A, of course, it works correctly, but B, it doesn't have security vulnerabilities. So we did a user study at some point, and it turns out actually developers tend to blindly trust. They say, oh, this code looks correct, commit. And so I do the cautionary tale is that, as you say, the cognitive, we might be losing a little bit of cognitive ability in that we trust the code that comes out of these generators too much, and we forget how to do a security audit and make sure that the code doesn't have actually security vulnerabilities in it. So the lesson that I really want to stress is, fine, it's great to use these code generators, but you also always have to very carefully look at the code that comes out and make sure that, of course, A, it works, and B, that it didn't introduce a security vulnerability. This is much harder than it sounds,
Right.
but
Yeah.
we have to keep that in mind.
I mean, that's sort of the name of the game, right? Everyone, even the researchers at the Frontier Labs, are thinking about how to scale evals and benchmarks and how to properly have oversight into these models, especially given the multimodalities that they have, right? Once you have that cracked, then having accountability measures over what these models say and do, people are like inspecting the chains of thoughts for these things, and these models are being deceitful for reasoning, right? But once you have better interpretability over these models, then you can maybe slap on verifiability and trust over the model that was trained in a certain way that has these properties, that behaves as expected because we've sort of observed that it expects that it has these properties, and it's not producing, let's say, like faulty code, right? That model is the one that's being used in these Claude Code or coding products, generally speaking. I think that will be pretty critical going forwards. So maybe one last question before we wrap up here is, what are you particularly excited about in AI crypto and AI crypto, and what areas do you think we need to spend more time and resources on that you think have been relatively under-indexed? Maybe Ali, do you want to kick it off?
Sure. I think that one of the most interesting open problems is the problem we talked about attribution. Somehow getting a sense for the way that a machine learning model, an agent, is trained, and being able to attribute back to providers of data, and be able to know where a lot of the intelligence of a model ultimately comes from would be enormous, just for building the right business models around AI. That I think otherwise we would just end up in a world where the ultimate source of intelligence for an LLM, which is the data, may no longer have an effective business model. And so then the question is, why then should anyone bother to create all of that data and to contribute it? And if there isn't really a good incentive for people to do that, then maybe we just end up in an impoverished version of the internet where there isn't any new content or new data that could then be used to train the next generation of an LLM, and we just kind of get stuck or stagnant in the current world with whatever it is that we've got so far. But kind of the future data is far less rich than it currently is, because there's no longer a strong incentive to create it. And I'm sure there will be things that people figure out, but I think that a good solution to this problem can unlock to the right incentive structures and business models for the space, for both kind of crypto and AI in this intersection. So that's, I think, an interesting area, which I think is also a very hard problem, but probably huge if someone solves it.
I think the fear that Ali is bringing up is that content providers will no longer share their content on the internet, right? Because they're just worried that it's going to be swallowed into these training data, and their work is going to go down. Basically, they're not going to get any compensation for their work. So it's quite worrisome that we might be moving into a world where new content is guarded, and it's only provided to your close customers or your very close fans. with additional, DRM protections, so it can't be given away to train models and such. So that would be really unfortunate if that's the world we end up with. Hopefully, proper compensation methods will be worked out. I have to say, maybe in terms of concerns, I do want to bring out one topic, which is this: there's a very large and growing field called adversarial machine learning, or rather, the security of machine learning, which is basically studying how well these machine learning models do under attack. Yeah. And I just wanted to bring it up because I feel like we can't talk about this topic and not bring up this issue that when you have an agentic model that can actually take actions in the real world on your behalf, that model could be confused into taking harmful actions on your behalf. Yeah.
100%. Yeah.
These attacks, there's a name for these attacks. They're called prompt injection attacks, where I kind of inject some data into your model and into your prompt, really, and I modify what the model is doing as a result. And now all of a sudden, bad emails get sent around, or, some proprietary information gets leaked, or the wrong data gets sent to the wrong person. And so this is actually something that, again, this is a growing field on machine learning security. And we have to make sure that whatever agentic systems are deployed, obviously take proper precautions. We've already seen a number of problems in this
Right.
space. So,
Right. I mean, another way of looking at it is social engineering, right? That's like one of the most widely used tactics of manipulating like systems. And because the interface to these agents is natural language, you end up with sort of the similar tactics of getting this agent into the right state of mind to persuade it to do something that, maybe the agent deployer didn't intend for it to happen, whether that's economic or not. I mean, it is relatively concerning that these agents are becoming more mature economic actors. So 100% that.
which actually ties into the kind of
that's
the
definitely
second point. This is something that Ali brought up before, which is that this concept of a proof of humanity is going to become more
Mhm.
more and more important over time. Yeah, when you interact with a remote party, you have to be able to tell whether you're interacting with a human or with an agent. Yeah. And so this proof of humanity is going to become a fairly important concept. And again, that's something that obviously the blockchain plays an important role in.
Yep. Awesome. Well, with that, I think we can call it. But yeah, thank you so much for taking the time, guys. Dan, Ali.
Thank you so much.
Yeah, thanks, Nima. This was great.
Yeah. Awesome. Take care.